Okay, video 5. There's going to be 2 videos that go with section 7.5. This is the first one. We're going to review area and perimeter quickly and then talk about scale drawings. So the targets for this section or this video are to find area and perimeter. That should be review, okay, of a polygon. So we're mostly worried about rectangles here. And then use scales to find missing lengths. Okay, so let's just review what we know about area. Area is two-dimensional. Okay, we kind of commonly refer to it as the space inside a polygon or inside of a shape. So for example, if I find out how much area is inside this rectangle, that's the area, right? And we know for area, so let's go ahead and find these areas. We know for area of a rectangle, we do length times width. So here, 9 times 6, 3 times 11, 7 times 13, which I typed in, okay? But let's talk about the units. So if I'm looking at the area of this rectangle, I'm actually going to look at how many little square feet are in here to cover up this rectangle, right? It's 6 square feet this way, 9 feet this way. How many little total square feet would it be to cover it up? Okay, this is chapter 7, video 5. Goes along with section 7.5. There's going to be a video 6 that also covers the second part of this section as well. So our targets for this video are going to be just how to review how to find area and perimeter of a polygon. And here we're mostly just worried about rectangles. Do you remember how to find area and perimeter of a rectangle? And then also to use scales, and we'll talk about what those are and what they look like, to find missing lengths. Okay? So our quick review of area and perimeter. Let's kind of redefine what those are. So area is two-dimensional, perimeter is one-dimensional. Area we refer to as like the space inside this shape. And perimeter, we usually describe it as the distance around the outside of a shape. For example, if I start here and I go 9 and 6 and 9 and 6 back to where I started, adding up those lengths. So we say add up the outside edges. And I know this is review for you. Okay? But we do want to talk about what units we get because we're going to use units a lot in this section and chapter 9 as well. Okay. So when I calculate area, imagine this rectangle is 6 feet long this way, 9 feet wide this way. Well, when I'm calculating the area, we're actually finding how many square feet, right? How many of these little squares would it take to cover up the whole thing? So we use square feet or square inches or square centimeters when we're calculating area. Okay? So this one would be, we know for a rectangle is length times width for the area. So 9 times 6, 54, and my units would be square feet. 3 times 11 gives me 33 square feet for number 2. 7 times 13, and I typed that in, 91 centimeters squared or square centimeters. Okay? So that's area. And then we talked about the perimeter of this one. 9 plus 6 plus 9 plus 6. If I add that up, I get 30. And that's just normal units, feet, right? This distance around the outside, 30 feet to get back to where I started. Or 3 plus 11 plus 3 plus 11, I get 28 feet. Or 7 plus 13 plus 7 plus 13, I get 40 centimeters. Okay? So, quick review. We already know how to do that. Let's move on to a scale. So, a general rule for us, when we talk about a scale, we mean a ratio that compares two measurements. Yep, if you can fit it on there. A ratio that compares two measurements, okay? So I'm going to give you some examples of things that have scales. We're going to talk about 4 different ones that might come up in this chapter. We could think of a map, whether this is a paper map or a map on your computer or your phone. It has a scale. Blueprints. And I'm going to show you an example of a blueprint right now. Oh, and a map. So here's an example of a map from your textbook. Oh, there's a little bit of a glare there. Here's the scale, right? They're telling you this map is drawn to a scale where every centimeter on the map is 320 meters in real life. It's a map of Central Park in New York City. Here's kind of like a blueprint. A blueprint just means pretty much a map of a room or a building. So see, this is a reduced drawing. It was a blueprint. It got shrunk down. 1 inch is equal to 16 feet. Okay, so here's another example of a scale. It's that ratio of how big is something in the drawing compared to how big is the actual thing in real life. Okay. What else has a scale? Scale drawings. So a lot of times things like a science book will have a scale drawing of a cell or a scale drawing of your heart or all different things, right? A dinosaur could be a scale drawing. Anything that's really big or really small and you're putting it onto a piece of paper probably has a scale. And then also toys and models. So like a toy car, a model train, those kinds of things sometimes also have scales. Okay? So what's an example of a scale? Well, a scale would be something like you saw in the book examples where they tell you like 1 inch equals 5 miles on the map. 1 inch on the map is 5 miles between those 2 points in real life. Okay? Or we can also, and we're going to see these as well, talk about scale factors. So scale factors are still a ratio, but it might just say simply like 1 to 10, where whatever is 1 centimeter is actually 10 centimeters in the real thing. Or 1 inch is actually 10 inches in the real thing. So this basically is like an easy arrow. It's just telling you, hey, it's 10 times bigger. Or a lot of times your toy cars and such will be like 30, I don't actually have toy cars, I'm not sure, but something like 32. It's the actual car is 32 times bigger or 64 times bigger. Okay? Or we often just write it like this. Hey, it gets 10 times bigger. So you'll see questions that say if this is the scale or the scale factor we're using, everything in real life is actually 10 times bigger. Okay? I want to point out that it could also be a fraction. So we could say a scale like this, which is telling us, hey, actually everything is only half as big. Okay? So we'll look at more examples of this, but I want to include in this video that we are going to be able to identify corresponding sides. When we look at scale drawings, so here are some examples of scale drawings. Move up a little bit. We need to be able to find corresponding sides that go together, and then we're going to be able to find missing side lengths. So this is just the first half of this section, but let's go through these examples. Okay? Identify the corresponding sides. So I'm going to color code. I'm going to get my highlighters and color code. You can do this with me or not. But I'm going to find corresponding sides. For example, these short sides over here, they go together, right? They kind of pair up, they match up. Those are corresponding sides. Or this longer side down here goes with that longer side there. Those are corresponding sides. And these are corresponding sides. And if I grab one more color, I could say these sides go together. So I use color coding a lot to help us just kind of see the corresponding sides. Okay? I'm going to go ahead and find corresponding sides on these as well. You can follow along with me, right? Those sides would be corresponding. These sides would be corresponding. And these ones and these ones correspond together. and this one with this one. Okay, now in these pictures, they're all kind of facing the same way. Nothing has gotten turned or twisted or flipped or anything, but just be aware, sometimes it could. You might see where one of the triangles is turned or one of the shapes is flipped, so just pay attention. We like to say like short with short. These short sides are always going to correspond, the long sides are always going to correspond. Okay, that's the first part of it, being able to do that. And then finding missing side lengths, okay, is what you'll be asked to do. So I want to back up and say that these are scale drawings, okay? So we found the corresponding sides of the scale figures or scale drawings, and now because we know that there's a scale between these, we can use that to find missing side lengths, okay? And I'm going to show you a couple ways. First thing is I might notice these corresponding sides. What happened to that number? You might notice an easy arrow, right? It got multiplied by 4. Cool. Well, that easy arrow has to match here. So this also has to get multiplied by 4. So I could figure it out. It's 24. Okay? Now, if I'm going the other way, right? I'm going to switch colors. If I'm going this way now, it's not getting bigger, it's getting divided by 4. And I can check that here, 8 divided by 4 to get 2. So this number would be 20 divided by 4, or 5. I just want to point out that if you see easy arrows like that, you're welcome to use them. But something that will always work, okay, 2 to 8 is that ratio of the side lengths. So 2 to 8 is going to be the same as 6 to x. And I could cross multiply and I'd get 24. Okay, or I'm going to come over here where I have a little bit of room. I could say again, 2 to 8, those are corresponding sides that go together. Y to 20. And we can set up proportions. So anytime you see scale figures, you can use proportions to find that missing length, right? Cross multiply and we'd get 5. So let's use proportions here, okay? I'm going to find corresponding sides that I know go together, like this. Cool. 78 to 13. And then here's the side I'm looking for. X goes with 16. And if I cross multiply those, which I did, and you can do it quickly, if I cross multiply those, I get 96. Check that with me and see, but you should get 96 right here. And I'm going to double check. I know the numbers on this triangle are bigger. 78 is bigger than 13. Oops, 96. 96 is bigger than 16. Yes, it looks right. Looks reasonable. Okay? So we've got one more down here. If you see an easy arrow, for example, I'm just going to point out, well, I'm going this way, the easy arrow here would be divide by 2, right? So you could divide by 2 and get that. You're always welcome to take an easy arrow if you see it. But we can also just always do proportions. 9 goes with 18. Those are corresponding sides. X goes with 6. And then cross multiply. Or maybe you set it up and then you look for your easy arrow. Make this a little higher. So maybe you notice here, oh, yep, divide by 2, divide by 2, and we get 3, okay? Or cross multiply. So proportions are going to be big in this section as well, using them to find missing side lengths, okay? All right, we'll do more of this certainly in class, but that'll get you started.